Okay, let's unpack this fascinating deep dive. And we're jumping right into a story that, well, it really grabbed headlines back in 2003. Sounds absolutely wild.
It does. The story of Andrew Carlson. This guy, he gets arrested, right, for some really suspicious stock market activity. But the gains were just off the charts.
Off the charts is putting it mildly. He supposedly started with, what, just $800?
$800.
And somehow, in like 2 weeks, turns it into $350 million. I mean, naturally, the FBI steps in, thinking insider trading, obviously.
Right, that's the logical conclusion.
Yeah.
But when they actually questioned him, his explanation was, well, something else entirely.
Yeah. What do you say?
He claimed he was a time traveler.
A time traveler.
Yeah, specifically from 250 years in the future. Said he just, knew how the market was going to perform.
Okay, wow. And this is where it gets even weirder, right? Because they couldn't find any trace of him.
Exactly. Investigations turned up basically nothing. No records of an Andrew Carlson existing anywhere before December 2002. It's like he just appeared.
And then he disappeared again.
Just like that. Before his bail hearing was even scheduled, he vanished. Poof. Gone. Nobody ever heard from him again.
So you're left scratching your head. Was he really from the future? Or something else? A hoax? I don't know, elaborate prank?
It's this incredible mystery, and it's kind of the perfect starting point for our topic today.
Yeah.
Time travel itself.
Right. Is it just the stuff of, sci-fi movies?
Yeah.
Or is there actually some real science behind any of these ideas?
And that's our mission for this deep dive, really. We're going to explore the scientific concepts. Using the material you've got there as our guide, we'll look at what science suggests might be possible, maybe even now, what could be on the horizon in the future, and, well, what seems like it's going to stay firmly in the realm of fiction all through that scientific lens.
Okay, sounds good. So where does this whole modern idea of a time machine even come from? Did someone specific invent the concept?
Well, for a lot of people, the image really clicks with H.G. Wells, his novel from 1895, The Time Machine.
Ah, right. The one with the actual, physical machine you sit in.
Exactly that one, with the livers and the crystal bits. That book really popularized the idea of a purpose-built device for traveling through time, going forwards and backwards.
Not just like falling asleep and waking up in the future.
Right, an intentional act using technology. And even though it was fiction, pure fiction back then, it really captured the imagination. It kicked off loads of public interest, inspired actual scientific thinking down the line, and of course, countless movies.
Yeah, speaking of movies, the source material mentions that sci-fi depicts time travel in a whole bunch of different ways. It's not just one method.
Oh, absolutely. If you look at films, you see all sorts of different mechanics, sometimes it's just one-way travel to the future. You go forward, but you can't come back.
Like in Interstellar, where he goes off and his kids get old back on Earth.
Exactly. A really powerful example of that. He jumps ahead, decades pass for his family. Very poignant.
Then there's the more, maybe, classic idea. Instantaneous jumping.
Yeah, like Back to the Future with the DeLorean, or The Girl Who Leapt Through Time. Usually involves some kind of machine or a special ability. Zap, you're there.
Or sometimes a person stays still and time just rushes around them.
Right, like using the time turner in Harry Potter. She stands there, and the world rewinds or fast forwards around her.
And there was that movie Primer, which had a really different take. Slow time travel.
Yeah, Primer was interesting, very low-key. Spend a minute inside this box contraption, and you only go back 1 minute. Much more gradual.
And maybe the most out there one. Just flying really fast.
Yeah, the old Superman trick from the 1979 movie. Flying faster than light to literally turn back time. Definitely stretches physics a bit there.
Okay, so that's a fun range of sci-fi ideas. But the big question is, which of these, if any, actually have some basis in real science? Can we really do any of this?
Well, this is where it gets genuinely fascinating. Because traveling to the future, science says yes. That's actually possible.
Really? Not just theory, but possible.
Based on our current understanding of physics, yes. And the key here is Albert Einstein and his theory of special relativity.
Okay, Einstein. So this is grounded in some pretty solid science then.
Absolutely. He introduced this idea called time dilation, which was, well, revolutionary at the time. Before Einstein, you had thinkers like Isaac Newton.
Right, he thought time was constant, didn't he?
Exactly, like a big universal clock just ticking away at the same speed for everyone, everywhere, no matter what, unchanging.
But Einstein said no.
Einstein said no. He suggested time is more like a river. Its flow isn't always the same. It can speed up, it can slow down, and the things that affect its flow speed and gravity.
Okay, let's take the first one. Speed. The source calls it kinematic time dilation. How does moving fast change time?
The basic idea is this. The faster you move through space, the slower time passes for you compared to someone who's moving slower or standing still.
So if I zipped past you in a super fast spaceship, hypothetically,
Huh?
my watch would actually tick slower than yours back here on Earth. Yep.
That's precisely it. It feels weird, counterintuitive maybe, but it's a real effect. There's a simple way to think about it. Imagine two perfectly synced clocks. One stays on the ground, the other takes a trip on a very fast jet plane around the world.
Okay.
When that plane lands, the clock that flew will be slightly behind the clock that stayed put. We're talking nanoseconds, tiny fractions of a second, but it's measurable.
And this isn't just a thought experiment. They actually tested this.
Oh, yeah. The source mentions a really important experiment, the Hafele-Keating experiment, back in 1971. They literally put super accurate atomic clocks on commercial airplanes, flew them around the world,
Wow.
and compared them to identical clocks left behind. And guess what? The time differences matched Einstein's predictions almost perfectly. It proved he was right.
Okay, so planes make a tiny difference.
Yeah.
What if you could go much, much faster, like close to the speed of light?
Well, that's where the effects become really dramatic. According to the theory, if you could travel at, say, 99.9% the speed of light for what feels like 10 years to you.
10 years on my clock.
Right. When you came back to Earth, thousands of years could have passed for everyone else. The source mentions a figure like maybe 9,000 years.
Whoa. That's a serious jump into the future.
Yeah.
And there's a real-world example, isn't there? Someone who's actually experienced this, even slightly.
There is. Russian cosmonaut Gennady Padalka. He holds the record for the most time spent in space, over 879 days in total, whizzing around the Earth on the International Space Station at about 28,000 kilometers per hour.
That's fast.
It is. And because of that sustained speed, calculations show he's aged about 0.02 seconds less than he would have if he'd stayed on Earth the whole time. He is literally fractionally younger. He's traveled 0.02 seconds into his own future relative to us.
That's incredible. Even that tiny amount is measurable proof. Okay, so speed is one way time gets dilated. What was the other?
He had this amazing concept of space-time. Not just empty space, but a kind of fabric, like a stretchy mesh. And things with mass planets, stars, especially really heavy things like black holes, they sit on this fabric and cause it to curve or warp.
Okay, like a bowling ball on a trampoline.
Exactly like that.
Right.
And that warping, that curvature, is what we perceive as gravity.
Got it. So mass warps space-time. How does the warp slow down time?
The deeper you go into that gravitational well, the closer you are to the massive object causing the warp, the slower time ticks for you compared to someone further away, where the space-time fabric is flatter.
Okay. This sounds like the scenario in Interstellar near the black hole.
It is. The source points out that Interstellar depicted this effect pretty accurately. They visited a planet orbiting super close to that massive black hole, Gargantua.
Miller's planet.
Right. And the gravity there was so intense that for every hour they spent on the surface, 7 years passed for the crewmate waiting on the ship further out from the black hole's pull.
7 years per hour. That's extreme.
It is. And black holes are the most extreme examples we know of. They're so incredibly dense, they warp space-time dramatically, even bending light that passes nearby. We actually got that first amazing photo of a black hole shadow back in 2019 from the Event Horizon Telescope, showing that intense warping.
And this gravity effect isn't just for black holes or sci-fi movies, right? It affects us here.
Absolutely. It has real-world applications we rely on every day. Think about GPS.
My phone navigation.
Yep. Those GPS satellites orbiting Earth are moving really fast, so their clocks slow down a bit due to speed-time dilation, like we just discussed.
Okay.
But they're also much farther away from Earth's center of gravity than we are down here on the surface. Less gravity means their clocks actually speed up slightly compared to ours.
Oh, so they have both effects happening at once.
Yeah, exactly. One effect slows time, the other speeds it up relative to us. And scientists have to precisely calculate and constantly correct for both of these relativistic effects. If they didn't adjust the satellite clocks, your GPS location would drift off by kilometers every single day. It just wouldn't work accurately.
Wow. So relativity isn't just theoretical, it's built into the technology in my pocket. Okay, so time dilation, speed, and gravity lets you travel into the future. It's happening constantly, just usually on tiny scales. But the source mentions another potential way to get to the future, cryosleep.
Right. Now, this one feels a bit more like classic science fiction, but there's actual research happening. The basic idea is suspended animation.
Like freezing someone, like in Passengers or Alien.
Kind of, yeah. Putting the body into a state where biological processes slow right down, hibernation, basically, or even deeper.
So you're not bending time, you're just waiting it out.
Ooh. Pretty much. You're pausing your own biological clock while the rest of the universe keeps moving forward. And the source notes that NASA is genuinely exploring this. They're developing something called a stasis chamber.
For astronauts on long journeys.
Exactly. The idea is to induce a state of mild hypothermia, basically lowering body temperature slightly, to make astronauts sleep continuously for maybe up to 2 weeks at a time initially. It saves resources, reduces psychological stress.
And potentially slows down aging over a long trip. What's the science behind how cooling helps?
Well, basic chemistry tells us that lower temperatures slow down reaction rates. Cooling the body slows down metabolism, all the chemical processes that keep us going, that make us age. It conserves energy.
Is there any evidence this could work, even in extreme cases?
The source mentions a really remarkable case from Japan. A man was injured and lost outdoors, and his body temperature dropped to just 22 degrees Celsius. That's incredibly low. He survived for 24 days, apparently, in a state very much like hibernation. His metabolic processes must have slowed dramatically, which likely saved his life.
That's incredible. It shows the body can potentially enter these slowed states.
It suggests there's potential there. But full-on cryosleep, like in the movies, where you're frozen for centuries, that's still very much science fiction for now. Lots of biological hurdles to overcome, like preventing ice crystal damage to cells.
Okay, so summing up future travel. Time dilation via speed and gravity is real, proven physics happening right now, though significant jumps require extreme conditions we can't yet create. Cryosleep is a possible future technology, being researched, but not here yet.
That's a good summary. Future travel seems scientifically plausible, even inevitable on some scale.
All right, so the future looks potentially reachable. But what about going the other way? Can we go back in time?
Now that's where things get much, much trickier. The challenges seem, well, enormous compared to future travel.
But I mean, in a way, we can see the past, can't we, looking at stars?
We can observe the past, yes. The source brings this up. Light travels fast, but not infinitely fast. So when you look up at a star, say, 100 light years away.
You're seeing light that left it 100 years ago.
Exactly. You're seeing the star as it was 100 years in our past. Look at the Andromeda Galaxy, our nearest big neighbor, and you're seeing light from 2.5 million years ago. So we can look back, but that's very different from physically going back.
And Stephen Hawking had that famous experiment trying to find actual visitors from the future, didn't he? The party.
He did. It was quite clever and a bit tongue-in-cheek. Back in 2009, he threw a party at Cambridge University, complete with champagne and balloons.
Sounds nice.
But here's the twist. He only sent out the invitations after the party date had already passed.
Huh. So only someone who could travel back in time would know about it and be able to attend.
That was precisely his logic. If travel to the past is possible, he reasoned, then surely time travelers from the future would eventually find the invitation and pop back to his party.
Brilliant. So,
Yeah.
did anyone show up? Future guests?
Silence. Nope, not a soul. He sat there alone. His playful conclusion, maybe this is experimental evidence of a sort, that travel to the past isn't possible. If it were, wouldn't we have been visited by now? Where are all the temporal tourists?
It's a fun thought experiment. But does the actual physics, like Einstein's theories, completely forbid going backwards?
Not entirely. It's highly theoretical, but Einstein's general relativity equations do contain solutions that could potentially allow for pathways back in time. These are often referred to as closed time-like curves, or CTCs.
Closed time-like curves, what are those?
Imagine a pass through space-time that loops back on itself. So if you could travel along this curve, you could end up back at an earlier point in time and space.
Like a loop-the-loop in time.
Mm.
And how might one of these CTCs form? The source mentions wormholes.
That's one of the main theoretical mechanisms discussed. Wormholes, sometimes called Einstein-Rosen bridges, are hypothetical shortcuts through space-time. Imagine bending the fabric of space-time so much that two distant points touch, creating a tunnel.
A tunnel connecting different places or different times.
Potentially both. Some theories suggest that if you could manipulate a wormhole in the right way, perhaps by moving one end at relativistic speeds, it could connect different points in time, creating one of these CTCs. You could theoretically enter one end and exit earlier.
Okay, but this is purely theoretical stuff, right? We haven't found any wormholes.
Not even close. It's deep in the realm of theoretical physics. The source mentions Nobel laureate Kip Thorne, who did a lot of work on this. He suggested that maybe microscopic wormholes pop in and out of existence all the time at the quantum level.
Tiny ones.
Very tiny and fleeting. But to make one large enough and stable enough for a person or a ship to travel through, that would require immense amounts of energy, and not just any energy.
What kind of energy?
It would likely need something called negative energy, or
Ugh.
possibly exotic matter with negative mass density. This is stuff that, as far as we know, doesn't actually exist, or if it does, we have no idea how to create or handle it.
Negative energy, what would that even do?
It's thought it would have anti-gravitational properties. It would push space-time apart, essentially propping the throat of the wormhole open and preventing it from instantly collapsing under its own gravity, which is what normal matter and energy would cause it to do.
Okay, so step 1, find or build a wormhole. Step 2, find or create negative energy, something purely theoretical to keep it open. Sounds like a pretty big hurdle.
Huge hurdles. We're talking science fiction levels of technology and physics we don't yet grasp. But even if you could solve the engineering problems, there's perhaps an even bigger issue the source highlights: paradoxes.
Ah, yes, the brain-twisting problems with changing the past.
Yeah.
Like the classic grandfather paradox.
The most famous one, everyone brings it up.
Go back in time, kill your own grandfather before you meet your grandmother.
Right. If you succeed, your grandfather never has your parent. Your parent never has you. So you are never born.
But wait, if I'm never born, how could I have possibly traveled back in time to kill my grandfather in the first place?
Exactly. It creates a logical impossibility, a contradiction. The cause, you traveling back, eliminates itself. How can that reality sustain itself? It seems to break the fundamental rules of cause and effect.
So how do theorists or sci-fi writers try to get around that? The source mentions the multiverse idea.
That's one popular proposed solution. The many worlds interpretation, or multiverse theory, suggests that every time a decision or quantum event occurs with multiple possible outcomes, the universe splits.
So infinite parallel universes.
In theory, yes. So, in this view, if you travel back and, say, prevent your grandfather from meeting your grandmother, you don't actually change your original timeline. Instead, your action causes the timeline to branch off, creating a new parallel universe where you were never born.
Ah, so my original universe where I was born and did travel back remains intact. The paradox is avoided because the change happens in a different reality.
That's the idea. It neatly sidesteps the contradiction within a single timeline. You just created an alternate history, not erased your own.
Okay, that's one way to think about it. What's the other major paradox mentioned? The predestination paradox.
Right. This one's kind of the opposite of the grandfather paradox. It suggests that you can't actually change the past because any attempt you make to alter it was always part of the history that led to the event you were trying to change.
So you're destined to cause what you were trying to prevent.
Yeah.
Your actions are already factored in.
Exactly. The source gives an example. Maybe you learn your friend had a terrible accident at a specific time and place. You travel back intending to stop it.
Okay, makes sense.
But maybe in your rush to get there, you inadvertently bump into someone who then drops something, which causes your friend to swerve and have the exact accident you were trying to prevent. Your presence caused it.
Oh, wow. So you were always meant to go back, and your attempt to change things is actually what makes them happen. It's a closed loop.
It's a deterministic loop. You can't escape fate, essentially. Many films explore this, like 12 Monkeys, Time Crimes, even The Time Traveler's Wife and the movie Predestination are built around this kind of inescapable loop.
So traveling to the past isn't just a mind-bending physics problem with wormholes and negative energy. It also seems to potentially break logic itself or lock you into inescapable cycles. It feels much, much less likely than future travel.
Based on current science and these logical hurdles, yes. Traveling backwards in time faces enormous challenges, both physically and conceptually. It seems far more speculative, perhaps even impossible.
Okay, so we've journeyed through the science, the theories, the paradoxes. Let's bring it back to where we started this whole conversation. Andrew Carlson.
Right, the supposed time-traveling stock market genius from 2003.
Given everything we've just discussed, that future travel via time dilation is, scientifically sound, but past travel is fraught with theoretical gaps and paradoxes. What does the source material finally tell us about Carlson? Was he real? Was it a hoax?
Well, the definitive answer, according to the source material we have, is that the entire Andrew Carlson story was fabricated.
Fabricated, you mean completely made up?
Yep. It originated in a publication called the Weekly World News.
Oh, I think I know that one. Didn't they run stories about Bat Boy and Elvis sightings?
That's the one. Known for its, shall we say, satirical and completely fictional stories. It was basically supermarket tabloid fiction.
So Carlson was just another one of their wild tales.
Exactly. The problem was, apparently, some other more mainstream news outlets, the source mentions Yahoo News specifically, picked up the story and reported it as if it were actual
Oh,
news.
wow. So it escaped the fiction section and got treated as fact.
It seems so. It spread online and became this urban legend. But the bottom line is Andrew Carlson, the time-traveling investor, pure fake news, never happened.
Huh. Well, after all that buildup about the mystery, that's almost disappointing.
Maybe a little,
Oh,
but it serves as a really important point, doesn't it?
how so?
It highlights the crucial difference between captivating stories and actual science. While the Carlson story was fake, the science we talked about, particularly traveling to the future via relativity, that part is absolutely real.
Right. Time dilation due to speed and gravity isn't a hoax. That's measurable physics.
Exactly. That's happening right now, affecting GPS satellites, astronauts, even us in tiny ways. The universe does allow for time to be flexible. We don't need a fictional stock trader to prove that.
Okay, so let's recap this deep dive then. We started with that intriguing but ultimately debunked story of Andrew Carlson.
The fake time traveler.
Then we explore the actual science. We learn that traveling into the future is theoretically sound, even proven on small scales, thanks to Einstein's special and general relativity time dilation caused by high speeds and strong gravity.
And we touched on cryosleep as a potential, though still futuristic, technological path to experiencing the future by slowing biology, not bending time itself.
Then we contrasted that with the huge challenges of traveling to the past. It relies on highly speculative concepts like stable wormholes needing theoretical negative energy.
And bumps up against fundamental logical problems, the paradoxes, like the grandfather paradox and the predestination paradox, which question whether changing the past is even logically possible.
And finally, we came back to confirm that the Carlson story that kicked us off was indeed just a piece of fiction that got mistaken for fact, drawing a clear line between sci-fi ideas and demonstrable science.
Yeah, the reality of how time actually works, according to physics, is already pretty mind-bending without needing fabricated tales.
Absolutely. Which leads us nicely into a final provocative thought for you, the listener, to mull over. Given that future time travel through relativity is scientifically real, even if just in small increments now,
Hmm.
what are the really long-term implications?
Right. If we could eventually make significant jumps into the future, how might that change society? How would we measure lifetimes, plan societies, if people could genuinely experience time passing at vastly different rates?
Or, looking at it the other way, do those stubborn paradoxes associated with past travel strongly hint that it's just fundamentally impossible? Does their existence maybe protect the structure of cause and effect, reinforcing something basic about how our reality works?
Lots to think about there. The universe definitely keeps throwing mysteries at us.
It does. And exploring them, trying to separate what we know from what we imagine, well, that's always the most fascinating journey of all.
Keep asking questions. Keep exploring.